This is the AB 91-94 review. Calculators are allowed, and all three of these deal with some relationships that look like this, which we encounter in section 9.4. It's the whole exponential growth or decay, and our goal in part A is to find the value of k. So we've got the growth equation, k is the constant, t is measured in hours, and we've got that the bacteria colony doubles every 3 hours. So we can first isolate, or separate, I keep saying isolate, separate the variables, do our antiderivatives, isolate, separate, and rename, and we can say at time equals 0 we have an initial number of bacteria, so we can end up with that solution that we're going to shortcut from here on out. So here's our solution, and we were told that the bacteria colony doubles every 3 hours. So whatever I start with is going to be doubled after 3 hours, and my goal is to find k. So I would divide by y initial, and then I would log both sides, and then I would divide by 3. And I don't know if I give you that or if I give you the decimal. I think I give you the decimal. So let's do 1/3 times the log natural of 2, diamond enter, we get 0.231. So let's look at part B, and this time we're going to shortcut to the solution. The solution to this exponential form, this geometric growth, is going to look like, or excuse me, exponential growth will look like P equals P initial e to the kt. And we are told the atmospheric pressure triples every 50 kilometers. So that means I'll start with an initial pressure, I will triple it. I guess this should be an H, not a T, when I've gone 50 kilometers. So if I want to solve for k, then I will divide by P initial, then I'll log both sides, and then I'll divide by 50, which is approximately 1 divided by 50 times the log of 3.022. Last one, the voltage drops. Again, we have that law of exponential growth, so I can write down the solution will be V initial e to the kt, and voltage reduces 20% every 5 seconds. So that means if I start with 100%, I'm going to end with 80% after 5 seconds. So if I want to isolate k, again I'll divide by V initial, then I'll take the log, then I'll divide by 5. So on the calculator, 1/5 the log natural of 0.8 gives me a negative 0.045. Notice that the voltage is dropping, so that k is a negative number, whereas in the first two, the pressure was getting larger the further the depth was, or the larger that H was. Same here, we had bacteria colony was doubling, it was getting bigger, so your k was a positive number.